The event horizon paradox. Look into the night sky. You see points of light, galaxies swirling, the cosmic dance of creation. But hidden in that velvet darkness are the universe's ultimate secrets and its ultimate predators, black holes. We've all seen the simulations. A swirling vortex of darkness, a point of no return from which not even light can escape. The boundary of this abyss is called the event horizon, a name that sounds like it's from science fiction. And, in a way, it is. It's the universe's final curtain. Cross it, and the cosmic play continues. But you are no longer an actor. You are gone. But what if I told you that this terrifying boundary, this ultimate cosmic prison wall, might not be what it seems? What if the event horizon is the universe's most profound and terrifying magic trick? Welcome to the event horizon paradox. This isn't just a scientific puzzle. This is a story that challenges our very understanding of reality, information, and the nature of existence itself. It's a story with two main characters, and they are locked in a battle for the soul of physics. Our first character is the great Albert Einstein. His theory of general relativity is a masterpiece. It describes gravity not as a force, but as the bending of space-time itself. Imagine space-time as a vast, stretchy trampoline. A planet is a bowling ball, creating a gentle dip. A star is a heavier ball, a deeper well. But a black hole is a point where the trampoline has been stretched into an infinitely deep, bottomless well. The event horizon is the point on the slope where the angle becomes so steep that there is no climbing back out, ever. According to Einstein's elegant equations, if you were to fall towards a black hole, something strange would happen. To an outside observer, like us watching from a safe distance, time for you would appear to slow down. It would slow and slow and slow. You would appear to freeze, a ghostly image etched onto the event horizon for the rest of time, forever approaching, never arriving. From our perspective, you never actually cross. But for you, the astronaut on this one-way journey, everything seems normal. You cross the threshold. There's no neon sign, no barrier. You are simply inside. And then, according to relativity, you are met with the singularity, a point of infinite density where all the laws of physics break down. Space-time itself is torn apart. You and every bit of information that makes you you are erased from the universe, not just destroyed, but unmade. This is a clean, if brutal, story. The black hole is the ultimate shredder. But then, enter our second character, a young, fiery physicist named Stephen Hawking. In the 1970s, Hawking made a startling discovery. He realized that black holes aren't completely black. They glow. They radiate. They have a temperature. This is Hawking radiation. And here's the truly mystical part. This radiation isn't coming from inside the black hole. It's created from the very fabric of empty space, right at the precipice of the event horizon. Think of the quantum vacuum not as true emptiness, but as a bubbling, frothing sea of potential. Everywhere, in every inch of space, pairs of virtual particles are constantly popping into existence. A particle and its antiparticle. They usually annihilate each other in an instant, borrowing energy from the universe and paying it back almost immediately. But at the event horizon, the black hole's gravity plays a cruel game of cosmic keep-away. One particle falls in, while its partner escapes. The escape particle becomes real, stealing a tiny, tiny amount of the black hole's energy and flying off as Hawking radiation. This means, over eons, black holes slowly evaporate. They fade away, returning their mass and energy to the cosmos. It's a beautiful, poetic idea. But it creates our paradox. A terrible, universe-breaking contradiction. Where is the information? In our universe, information is sacred. It's a fundamental law. The law of conservation of information states that information cannot be created or destroyed. It can only be transformed. If you burn a book, the ash and smoke seem random, chaotic. But in principle, if you could track every atom, every photon of light, every wisp of heat, you could reconstruct the book. The information, the story, the words, the author's name, is still in the universe. It's just scrambled. Now, let's go back to our astronaut. She falls into the black hole. According to Einstein, she and all the information in every atom of her body are crushed into nothingness at the singularity, gone. But according to Hawking, the black hole eventually evaporates, leaving behind only a faint, featureless bath of Hawking radiation. This radiation is random. It's thermal noise. It contains no information about what fell in. It's the cosmic equivalent of shredding a book and then burning the shreds into a uniform, gray ash. The information is gone, truly gone. The universe has forgotten her. This is the event horizon paradox. Einstein's relativity says information is destroyed inside. Quantum mechanics says information must be preserved. Both are pillars of modern physics, and they cannot both be right. This isn't a small disagreement. It's a crack in the foundation of reality. So, who wins? Is the universe a relentless destroyer of history or a perfect librarian? This is where the story gets truly magical, and where our understanding of reality begins to feel like something from a far future myth. One of the most breathtaking solutions is the holographic principle. Imagine a hologram on your credit card. A flat, two-dimensional surface that, when you tilt it, creates a perfect illusion of a three-dimensional image. Now take that idea and apply it to the entire universe. The holographic principle proposes that our perception of a three-dimensional universe, you, me, the stars, the galaxies, is actually a projection, a magnificent, incredibly detailed illusion. And the source code for this illusion is stored on a distant, two-dimensional surface. And where's that surface for a black hole? You guessed it, the event horizon. Remember how, to an outside observer, the astronaut appears to be frozen on the event horizon. This isn't just a visual trick. This theory suggests that in a very real, physical sense, her information is encoded there. It's imprinted onto the fabric of the horizon itself, like data encoded on a cosmic DVD. Every bit of information about her is stored on this two-dimensional surface. The black hole doesn't destroy information. It stores it in the most efficient way possible, on its skin. When Hawking radiation is emitted, it's not random. It's subtly encoded with the information of what fell in, read from this vast cosmic hard drive. The evaporation process is like playing a movie backwards, carefully releasing the stored data back into the universe. The information was never lost. It was just translated into a language we are only now learning to read. This means the astronaut never truly enters the black hole in the way we think. From our perspective, her story ends at the horizon, encoded forever in its shimmering surface. And from her perspective, that's the final, mind-bending twist. What does she experience? Some theories, like the fuzzball or firewall hypothesis, suggest that the event horizon is not a peaceful gateway, but a violent wall of energy, a searing firewall of unimaginable heat that would instantly incinerate anything that touches it. Information is preserved because the object is transformed into energy right at the boundary, its data immediately added to the holographic film. Other, even more mystical ideas propose that the event horizon is a gateway, not to destruction, but to something else entirely. Perhaps it's a bridge to another universe, a white hole in a distant cosmos, or a different part of our own. The information isn't destroyed, it just leaves our stage and enters another. But the most profound, and perhaps the most beautiful, answer brings everything full circle. If the holographic principle is true for black holes, and the universe is showing us that information is more fundamental than space and time, then perhaps our entire cosmos is a hologram. Think about that. The screen you're watching this on, the feeling of your breath, the vast emptiness of space between galaxies, all of it might be a magnificent dynamic projection from a two-dimensional surface at the edge of everything, the event horizon of our observable universe. The black hole, then, is not a monster. It's a teacher. It's the universe's way of showing us the hidden rules of reality. It's telling us that the solid, three-dimensional world we experience is a beautiful illusion. That the true reality is written on a distant, two-dimensional canvas, and we are the living, breathing paintings. The event horizon paradox began as a terrifying conflict between our two best theories of reality. But in solving it, we may have stumbled upon the deepest secret of all, that the universe is fundamentally informational. It is a cosmic computation, a thought in the mind of something far greater. And we, conscious beings within it, are both the data and the ones reading it. The black hole's abyss isn't just a pit of destruction, it's a mirror. And when we stare into it, we are, in fact, staring at the deepest nature of our own existence. This is a conversation that is far from over. Physicists are still wrestling with these ideas, and every day we get closer to an answer. What do you think? Is reality a hologram? Let me know your thoughts in the comments below. I read every single one. If this journey to the edge of reality fascinated you, then do me a huge favor. Smash that like button and subscribe to the channel for more adventures into the cosmos's greatest mysteries. It really helps the channel grow. And if you're hungry for more, if you want to dive even deeper into the idea that our universe is a holographic projection and explore the multiverse of possibilities that spring from it, then I have something special for you. I've written a book called Holographic Multiverse, where we explore these concepts in breathtaking detail, weaving together physics, philosophy, and the sheer wonder of it all. The link to get your copy is in the description below. Thank you for watching. Remember to look up at the stars and wonder. Until next time.